Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things general chemistry related. On this video, we're going to learn about how the periodic table is laid out and some important information we can pull from it just by looking at it. Let's get started. When elements are arranged in an order of increasing mass, certain sets of properties reoccur periodically. We're going to learn more about the why this happens in Chapter 8, but right now we're going to really familiarize ourselves with how the table is laid out and what information we can garnish from there. So what you'll see is on a periodic table is that you have columns and rows. And so each thing tells us a different bit of information that we need to know. So there are 8 columns that exist, which represent our main group elements. And these are the elements that are commonly found in living things. And so you can see those that are highlighted, the group 1, group 2, and then group 3 through 8, which are found on the right side of the periodic table. Those are things that are most commonly found in living elements or living things. And this is where we're going to spend a lot of our time throughout the semester. We also have the transition elements, which are as well as the inner transition elements, which are normally pulled out toward the bottom of the table. Now, it's important for you to notice that the inner transition elements, although they've been pulled out to the bottom of the table, they actually reside right here. Because if you look at the numbers where you see 57 and then it jumps to 72 up here, well, that 58 through 71 have been pulled out to the bottom. And this really just helps us to observe the elements in a much easier format. Now, on the far left of your periodic table, those are where our metals are typically found. Now, metals are things that are considered to be good conductors of heat and electricity. They can be pounded into flat sheets or they're malleable. They can be drawn into thin wires or they're ductile, and they often are shiny. The thing that we want to remember most in chemistry is that these electrons that they have are going to typically be lost as they undergo some chemical change. So with our metals, we're expecting that they're going to form, when they're forming ions, they're going to form a positively charged ion by losing that negative electron. On the right side, including the hydrogen that's placed on the left side based off of some other properties, is where we find our nonmetals. Now, nonmetals tend to have exact opposite properties of our metals. So rather than being good conductors of electricity or heat, they actually serve as insulators. They are not ductile, they're not malleable, meaning they can't be drawn into thin wires or pounded into flat sheets. And again, what we care about in chemistry is that they tend to gain electrons during a chemical change. And as a result, by gaining electrons, you're going to take on that negative anion representation. All excluding that group 8, and we'll talk about group 8 in a little bit. And then the last main classification that we have on our periodic tables are our semimetals. The semimetals have properties that are found in between both the metals and nonmetals. And in later chapters, we'll explore those elements more. So there are a few names associated with some of the groups. So our group 1 elements, those are known as alkali metals. Alkali metals are those that are very reactive with water. Again, think about it. They only have to kick out that one electron to start undergoing a chemical reaction. They tend to be soft and they can easily combine with chlorine or oxygen to form soluble salts. Group 2, those are what we call our alkaline earth metals. Now, these are still somewhat reactive in water because we now have to have these 2 electrons that we're losing, and they also combine with chlorine and oxygen to form soluble salts. Group 8 are considered to be our noble gases, and noble gases are inert gases. That word inert simply means non-reactive. And if you think about it, the reason they would be non-reactive is because they have 8 valence electrons already. They don't want to gain or lose any electrons, so therefore they don't want to react with anybody. So they're considered to be inert. Group 7 represent our halogens. Our halogens are very reactive with other elements for a lot of the same reasons that group 1 was. Halogens, group 7, only have 1 electron that they need to gain in order to reach that closed shell configuration. And so these tend to often be involved in forming salt-based compounds. So if we put all this information together from this chapter, we should be able to look at the periodic table and deduce some information. So here it says the mass number of argon is 40. The element is in period where? So if we find argon, which is here, argon is in period 3. Now the period are the rows that exist in the periodic table. So there's the period, the row, and then the group or the column. So this is found in group number 3, in period 3. The element isn't found in group 8. And when we're writing our groups, we always show them in Roman numeral format. We show them in Roman numeral format. The element has how many protons? Well, remember that protons is equal to the atomic number. So this would have 18 protons. And then the number of neutrons would be based on 40 minus 18, which would give us 22. And then the atomic symbol for this would be, now including all pieces, would be argon symbol, 40 up the top, and 18 on the bottom to be completely correct. Next example, a neutral element has 12 electrons and a mass number of 24. Again, here the key word is that it's a neutral element. So that's going to help us to figure out some information. The fact that the neutral element has 12 electrons, that tells us that it also has 12 protons, which means we would indeed be talking about magnesium, which would have 12 protons. So it is found in the third period, third row. The element is in the second group. Again, we write it as Roman numerals. The element would have blank neutrons. So we would take 24 minus 12 to get 12 neutrons. And the atomic symbol for the element would end up being Mg, which is the chemical symbol. We would put 24 at the top, 12 on the bottom to complete our chemical symbol. All right, let's try another example. It says the atomic symbol for carbon is 12,6C. The element is in which period? So again, locate carbon on the periodic table. We see it here. So that is in period 2, row 2. It is in it is in group 4, column 4. The element has blank neutrons, so 12 minus 6 gives us 12 neutrons. And the neutral element would also have 6 electrons because, again, my protons would equal my electrons. Okay, let's try a few examples with our naming or identifying based on what group they're found in. So here it says name and write the symbol for 3 halogens. So remember, our halogens represent group 7. So we could write down any of the following. We could write down fluorine, chlorine, bromine, iodine, astenine, as such. The next one says name and write the symbol for 3 alkaline earth metals. Remember, alkaline earth metals are those found in group 2. So we would again identify group 2, and we could put beryllium, magnesium, calcium, strontium, barium, or radium. I hope this video helped you get familiarized with how the periodic table is laid out. Be sure to subscribe, comment, and like below for future content. Have a great day. See you guys later. Bye.